In this part, we will explore the product's features and capabilities for threat analysis, investigation and response within industrial control systems environment, which can be IT or process-related in their nature. In the dashboard section, we can see devices which require attention. They are highlighted in red, which means that devices have associated events. In the list of events, we can see last registered events, some of which may be the reason for highlighting. In the situational awareness section, we can observe summarized information. In our case, it contains detected unauthorized device, network interactions with a public network, and information about potential malicious activity received from endpoint protection software. We can try to assess this situation on the network map. Here, we select the time interval of first signs of suspicious activity. As we can see, a new node appeared on the map, which was not visible before. Obviously, this node was not authorized initially in our system. Let's now move on to the events registered about the same time. The events are filtered to simplify the analysis. First of all, we can observe a correlated incident which informs us about new device detection. We see that a new device with a certain MAC address was discovered and some generic name was assigned to it. Further on, device information was enriched from the network traffic. Initially, information about the hardware manufacturer was obtained, then its IP address, next the information about device network name, finally operating system version was detected. At the same time, we can see events about blocking this unauthorized device at firewall, with which the solution has API integration configured. Then we can notice information that device was permitted on the firewall. This may indicate that device status in the product was changed from unauthorized to authorized, and thus it was granted network access. Later, we will see that this will result in the attack scenario development. In the absence of network equipment integration, we would receive a generalized incident about new device discovery on the network. This incident would look similar to the one shown on the screen. Let's change status for these events to resolved and proceed to further scenario analysis. Let us assess the situation based on information provided on the network map. To do this, we need to set the time interval sliders to view network activity on the network map. Here we can see that from a previously connected unauthorized node which was allowed into the network, unauthorized interaction was carried out with a node in the dispatcher center, which, in its turn, performed unauthorized interaction with public network. Also, following the red links, we can see that unauthorized network activity involved the power substation facility, where the industrial protocol gateway was affected. We can also notice that Scada server is highlighted with red, which indicates that there are unresolved events. Let's check corresponding events. In total, we see about 50 events that were registered within this time period. We can review them one by one or switch to device or interaction filtered events directly from the network map. Let's start with Dispatcher Center node. By selecting device on the map, we highlight all its communication links and can proceed to the unresolved events related to this particular node. Now we see a filtered list of events that are related only to the previously selected node in the dispatcher center. The first thing to pay attention to is the intrusion detection subsystem event. In our case, this event indicates the fact that the unauthorized node was using Remote Management PsExec utility. We can assume that as a result of Remote Management utility use, access to the node in the dispatcher center was obtained. Going further on the list, let's check signs of malware activity on host incident, which was correlated from several endpoint protection events received from Kix for nodes due to configured integration with Kix for networks. Here we can see modify registry and launch of unauthorized or untrusted application on host sub-incidents. In these events, we can observe that some script was executed. In the event graph for this activity, we can examine the details of its execution. Notice that this script was delivered to the node as a result of processes sequential execution. The first was psexec, then autorun.exe, which started script extraction and execution. Finally, script triggered one of endpoint's protection modules, allowing Kix to build a correlated chain of suspicious activity events. Analyzing sequence of recorded events, we can see information about the identified unauthorized network interactions. Network interactions are considered unauthorized in case they are not included in allow rules, generated during product learning mode or configured manually. We can observe that many network connections were made from an unauthorized node to a node in the dispatcher center using TCP, RPC, SMB protocols. The next incident is quite interesting as it focuses on industrial process control domain. We can see a set of system commands which were discovered in IEC 104 industrial protocol traffic. These system commands indicate that the control command's execution sequence, specified in IEC 104 protocol specifications, has been disrupted. Unexpected command terminations, sequence mismatches, and multiple commands were detected. We can check detailed events description to identify the cause of such abnormal interaction behavior. Both communicating nodes have endpoint agent installed, which provides detailed telemetry about nodes' operation and running services. Hence, we can get information about applications initiated these abnormal communications on each node. On the industrial gateway node, we can see Siemens IEC 104 protocol driver located in Siemens folder, which participates in the network communication process. On the other side of the interaction, we have a starter.exe process launched from a temporary folder. This application looks suspicious. Let's continue to review other events recorded by the system and pay close attention to the events where industrial devices respond to requests with unknown addresses. We can see that the same suspicious process was involved in these requests. It obviously missed the correct control command address. That means submitted commands are not recognized on the industrial device. Considering this fact, it can be assumed that the suspicious process is acting randomly without having the correct address information. The product has captured and passed industrial gateway reply packets for IEC 104 protocol, which confirm that gateway received requests for the unknown command address. Now let's get to the next incident containing signs of malicious activity on the node. First of all, let's pay attention to the event that informs us of infected or probably infected object detection. Note that this event has an EDR tag. It means the event has extended endpoint telemetry available as well as malicious activity events graph. Similar as we observed for unauthorized script launch event, in the correlated incident, we can see execution of unauthorized or untrusted programs, log inspection events, and registry modifications, which all happened around the same time. All these events were correlated into one comprehensive incident. Let's take a look at infected object detection event details occurred in dispatcher center. Here we can see that the antivirus engine triggered at the 104.dll file. Also, we know suspicious starter.exe process was responsible for using DLL file. On the event graph, you can see that autorun.exe process started PowerShell from the command line. Recall that earlier we've reviewed an event about unpacking and running some suspicious PowerShell script in the dispatcher center. The graph shows that PowerShell was the source of malicious 104.dll file. In addition, the same PowerShell process launched applications, created files and made web requests as well as changed registry. Among web requests, we see multiple requests to a single public resource. Let us check whether any files were created or received during the request execution. We observe several configuration files, a suspicious starter.exe process, and number PDL files, probably WinCC graphical files. Additionally, we can filter the data by registry changes and analyze them. For each element of the activity event graph, there is a detection information area which contains file hashes, paths to them, and the account name which started corresponding process. Response actions are available here as well. In our case, we chose autorun.exe. Most probably it is the incident origin. We can prohibit its execution for preventing future incident reoccurrence on this device, which becomes possible because of integration with endpoint protection software. Additionally, we can check all other processes which were executed within this incident. We can see all started processes. PowerShell and cmd.exe are standard operating system processes. PSExec is also a well-known application. Among the observed processes, starter, exe, and autorun.exe are the most suspicious. Based on available information, we can export indicator of compromise file, which can be later used to detect these indicators on other nodes. Let's review the last incident related to dispatcher control node communication attempts to external address. In this case, we see node interactions with public IP address. Malware was downloaded from. Traffic is not captured from this network segment. Information about external network interaction was obtained due to integration with endpoint protection software. We can find detailed information in the event properties. Let's switch to Response Actions tab and check the status of Prevent Run action for autorun.exe on the Dispatcher Center node. As we can see that the task has been completed successfully. From the Actions Details area, we can disable run prevention or continue response by moving file to quarantine. Now we can go back to the network map and assess the situation on other nodes. Here we have one incident which contain endpoint protection events informing us about unauthorized file operations within specified monitoring scope on Scada server. We can notice that the file names in this event are identical to ones which were previously downloaded from public resource, and the type corresponds to WinCC graphical configuration files. It is worth noting that for Scada server, we do not see any unauthorized network communication events. We can assume that for Scada interaction, only allowed network communication protocols and links were utilized. On the map, we can pay attention to the highlighted links, which indicate presence of unresolved events. Let's focus on the communication between the dispatcher center and industrial gateway device and filter unresolved events. We once again see DPI events related to communication disruptions. Based on this demo scenario, a brief overview of Kaspersky Industrial CyberSecurity updated threat analysis and response capabilities was provided. The product capabilities are significantly enhanced due to tight integration between Kix for Nodes endpoint protection and Kix for Networks monitoring software. Through the integration, it became possible to substantially enrich solution events with endpoint-specific information, expand network inventory and monitoring capabilities, as well as provide registration, correlation, root cause analysis, and threat response capabilities within a single console.